Nats.io Community Office Hours. My name is Jeremy, and this is Nate, and we're here to talk all things Nats. So I know we have a few of you joining in right now, piling in. Thanks for joining us. We're on Riverside. That's kind of where we're doing our main Q&A, but we're also on YouTube. We're on LinkedIn. We're on X or Twitter. We're on Twitch. So you'll be able to join us there as well. Let me see if we're getting stuff going on our YouTube live stream. Okay, looks like we're live there as well. Good, good, good. Welcome everybody to another Nats.io Office Hours. For those of you who are just joining us for the first time, we just do this weekly for about an hour. There's not a ton of agenda. Mostly we just try to get folks geared up to ask some questions, and then we answer questions. I might do a little bit of drawing, an Excel draw. I might explain some concepts, but you could really ask anything about the Nats.io project, whether there's a particular feature that you're wondering about, or something that you're struggling with, or just a distributed systems concept in general. Now's the time to kind of ask it, and we might even have some Synadians here in the chat. So if you are joining us here on Riverside, or if you're joining us on YouTube, a place where we can receive chats, go ahead and let us know where you're coming from. Come say hi, and we'll welcome you, and we'll have a lot of fun talking about Nats today. So, hey everybody in the chat, be sure to let us know who you are. Hey Maurice, nice to see you again. Maurice is one of our Nats ambassadors, and we got to hang out with him at KubeCon last year, which was super super fun. So today we have a little bit of agenda. We might be reading some blog posts, and then again, like most office hours, we'll probably just like devolve into answering a bunch of questions and doing a bunch of drawing. So I'm gonna go ahead and share my screen, and we'll get all of this started. So, all right. Actually, I need to share my window.
Wayne's coming from his office leaf node. I love that.
Love it. Love it. Your LeafNode office. Yeah, we're all dialing into the main cluster right now, right? um, oh, does Riverside not allow emojis? That's a bummer. But we do appreciate your jokes, Wayne. Thanks for joining us. Um, all right. So today we have a couple blogs that are kind of just been kind of floating around here and there last couple months around Nats, but we also have last week we released a new version of Nat Server. Just a small update. But we should have like numerous fixes that have been coming in stability wise around Jetstream, which is good. So if you're kind of following the Nat server and you want to kind of see what's new, last week we did have a new release, fixed some panics, things like that. And I know we'll have probably another release soon after this that fixes a couple more things. We're in bug fix mode for the most part, which is great. But yeah, 2.10.18 is out. You might want to consider upgrading if you haven't already. There's some pretty decent fixes in here, which is great. And we're on the road to 2.11. Last time I checked with some folks, it looks like a September release is really what we're looking for. But there's a lot to like in 2.11, and so we're still working hard, kind of getting some wrapping up the scope for that, and then getting into kind of like test and release candidate mode, which will be super, super fun. So feel free to ask any questions about this stuff. We could dive deeper into different parts of Nat Server. I wanted to kind of pull up a couple of blog posts from the community. Some of these were posted on like the Nats server months ago, but I thought they would be fun things to kind of talk through. And I know this is on the Nats.io website. We don't have a dark mode yet. We really need to, because it's burning my retinas just trying to look at this. But yeah. Awesome. Welcome, Bastian. Thanks for joining us today. Wayne, always good to see you on. And thank you for the tea. I'm still enjoying all of the tea you sent me. It was delicious. Still is delicious. All right, so we'll kind of take a look at this guest post, and we'll kind of read through it and see what it's about. I actually haven't read it at all, so this is going to be new for me. It's called Delegate with Trust. It's on the Nats.io website. You can just look at the Nats blog. I think it's one of the more recent blog posts that we had. Yeah. We'll have to read this one too, the one that was published more recently. I think this would be a good one to also kind of throw in here. So I'm just going to toss this one in here as well. All right, but let's start with Delegate with Trust. Okay, so problem. Command handler doesn't know if the state is up to date. Source event is a source of truth. Subjects and events enforce the business rules, and is view up to date using the view as a projection to change event in state. So this looks like it could be like a an event sourcing style, or I'm hearing stuff hearing about events and commands, maybe some CQRS in there. But yeah, when speaking about async patterns, with other developers, they seem afraid of eventual consistency. However, it's expressed in the form of if the front end needs the answer directly, the business process needs to be validated with perfect data. My next page needs fresh data to display properly. With a messaging system, you have to wait for the message to be processed and the state to be updated. Then you can query it with trust. In the happy path, this could be something reasonable like 30 milliseconds, so it could be arbitrarily long if there's an interruption in the flow. Okay. With a classic CRUD system, you write your database and you query it with trust. How can I delegate the job and make sure they'll be done, or if, that I get an error when it can't be done? Let's dive into the use cases and tactics where I can gain some trust using Nats JetStream. Okay, so this is kind of talking in the context of like in a very simple application. When you have a database and you're talking directly to it in your application, there's this kind of like creation of trust, right? And or there's often this assumption of trust, right? That both of these parties that are talking to each other are ones that like are that they can be trusted. But maybe you're working in an organization where you're talking with some things that you can't completely trust. Maybe it's different business units that are interacting with each other, or maybe there's maybe you're interoperating with like different organizations altogether, or you have some form of delegation or decentralization in place. There's going to be, you can't lean on that implicit assumption of trust. And so when you're doing like event-based systems, you have to think about it a little bit differently in terms of trust, right? So let's kind of keep going and see where this takes us. Okay, there can only be one. I have a payment system, and in this system, we must withdraw the customer for a given order ID only once. Yep, yeah. Okay, so I get it. You can only, you don't want to debit somebody twice. Okay. Sadly, our partner who triggers a payment can call us multiple times, sometimes with a 1-day delay. Okay, interesting. Here, we use the subject per order to store its payment log. The subject will contain only one message, the withdrawal. Using published expectations, I can be sure that there will only be one subject per order payment. Yeah, cool. So like, this is kind of neat because you could do stuff like in Jetstream by saying, hey, just, make sure there's only one of these per subject. And you could even do stuff like, hey, we're going to throw an error. We're going to have Jetstream throw an error if, or reject any new ones for that particular subject. And this kind of ensures like a uniqueness. It's kind of like a uniqueness constraint inside of a database, right? Then they show some Jetstream code. The impatient clicker. The customer always clicks multiple times on the same button, so it calls the backend and duplicates messages. This triggers side effects multiple times, creating spam and downstream issues for business intelligence. But Nats Jetstream has a built-in deduplication system, based on message ID for a given time window. The window is configured in nanoseconds at the stream level. Okay, and then they connect some stuff. It looks like they set a duplicate window for a very, very long time. Maybe a little too long, if you ask me, but awesome. So
Is that 5 seconds? They say 5 seconds below, but
oh yeah, I forget what the duplicate window is configured in, and he's doing this in this is in Python, I'm assuming. Is this in Python?
no, it's JavaScript.
Is this JavaScript? Oh,
Yeah, you can use
wait,
underscores. Okay, yeah. It's just like parsed out.
Yeah, maybe this is set in like nanoseconds or something.
Yeah.
In the Go library, you use the actual time stuff, but yeah, maybe that's what it is. A good point. In my order process, I can't refund more than the price of the order. I can query my order subject. I can query my order subject like I would query my database. Data is up to date. Here I can check order passed and get the amount by the business rule. And so I wish this was syntax highlighted. We need to update the blog to get syntax highlighted in here, huh? Ryan actually asks a pretty good question around dedupe. Does dedupe happen on the server with source streams? Yeah, so deduplication actually happens on the server side. You basically, the way deduplication happens is you give it kind of like a window of time where you want to deduplicate, and then you have to kind of fill out a header. essentially that you'll deduplicate on. So it's all still driven by stuff that you give it. But like in your system, if you have like a unique ID for something that identifies like a transaction, for instance, you could just pass it that transaction ID, and rest assured, like in that given window, the NAT server kind of keeps track of that transaction ID and make sure that like no new ones will come in. So that's kind of like it's a pretty simple model for deduplication, but it can be really effective. The reason we have the rolling windows, you can't just have like indefinite windows where the NATs just keeps track of all of this stuff. Needlessly, right? Usually these things close out within a certain window of time. You're not expecting somebody to double click in like the span of a year, right? And so, making sure you get that window right can be really helpful because you could easily flood the NAT server if you expand that window too long and you just like send it a bunch of unique stuff, and that has to keep track of all of these things that they want to deduplicate and can never let go of them because you set a duplicate time window that's too long. So that's something to kind of keep in mind. But yeah, it's a pretty simple model.
Well, and Ryan was asking specifically about source streams. This might not really be his question, but I'm curious. With source streams, the deduplication would happen, or I guess is the window configurable per stream? So could you have a source stream
Oh,
that
that's a
has less
good
or more
question.
deduplication?
Okay, yeah, Ryan's asking actually a more interesting question, which is like
Yeah.
you have a stream and then you're sourcing from this stream into another stream. And so I actually don't know the answer to this. I'd have to look into it because like there's like this stack of like things that happen when a message kind of goes into a jet stream. But when you're sourcing, it is still using a consumer, but I'm not sure at what point of the stack. Like, does it hit the deduplication portion? That'd be interesting to kind of find out. You might have to test it out, but like presumably, if the header exists in there and this stream over here is configured with a dedupe window, that stuff would be deduplicated, presumably.
So you could have a
But
raw source stream and then a more heavily deduped.
right, like I mean, it kind of assumes that some properties would exist here where that raw source stream is like that raw source stream like has to have these messages with these headers in them and not deduplicate them. Like
Yeah,
the
there would have to be a
deduplication
need.
is not a but maybe what he's also saying is that you have two streams that are being sourced into this stream, and these might have duplicate messages in them, like across the two of them.
Oh, oh, that's
So
an even
Ryan,
more
I
interesting
don't
use
have
case.
an answer to your question, but I don't think it would be terribly difficult to like mock it out and see what happens. Um, this would be helpful to also put in the documentation if that's true. I kind of want to like go after this and test it out. Um, yeah, okay, so that's exactly what he's saying, where he has like this hub and spoke architecture. So we have like spoke, and they might have identical data in them. Now, what you'll need to do, Ryan, is like um, that data is not going to be like identified by its payload, but more by the header that you include for deduplication. And so, but like this could also just be like a hash of your payload if you really wanted it to. I mean, you could run into other problems that way, like a hash of the payload and the subject maybe, or if you have some other unique way to identify it. But yeah, like I'm curious to know as you're funneling things in a hub and spoke leaf node architecture and you're sourcing streams if this stream will deduplicate. My assumption is yes, like that it will, because I think pretty much sources still go through a lot of the same flow that like any other consumed message would go through. You just need to make sure that the hub is configured with deduplication, and that these spokes they obviously contain duplicate messages with the same kind of duplicate message ID. But that's like a really great question, and actually a really interesting use case too. Crazy that you
Yeah,
can model something like this in NATS.
that's cool. The only use case I was thinking of is if you want analytics on like how much duplication is happening between certain providers, you know. But
Yeah,
at that point, I don't know if that would be the right layer just to get those analytics.
yeah, and like I mean that's the interesting thing about all of this too is like depending on what you want to do, yeah, like you might want like you might want to do what Ryan's trying to do and take these multiple data sets and try to treat them as one unified data set, right? And at the hub. Or you might want to do, something different where you want to take into account like that these spokes exist in the hub world. And instead of, trying to merge them together and deduplicate them, these all get, remapped. These all get remapping for their subjects, right? Where instead of, the events.foo.123, it's now, spoke one dot events dot foo dot 123. It gets remapped. And this one is spoke two. And so spokes can pretend like they're the only ones in the world that exist, but the hub knows better and can then, remap all of these subjects to their spoke. And in this case, you would still have duplicate messages because they'd now be on different subjects. But yeah, and that kind of goes to show like there's a lot of ways to kind of spin this architecture depending on what your needs are and what you need to do. But like Nats is generally flexible enough to do all that stuff. Really, really great question. Folks who are joining us on YouTube, if you do have any questions, feel free to jump in and ask stuff. We're just going to continue with our Delegate with Trust blog post and see how things go. I'm going to see if were there any other questions.
I will drop a link in some of the chats, by the way, if anybody's curious to pull up the blog post as well.
Okay. Yeah, back to Delegate with Trust. So message processing like this can help build a state from all previous events. So now he's talking kind of about some lightweight like event sourcing, basically being able to take all the events and assemble some sort of projection out of it. And it looks like he's doing it in aggregation of some sort. He has a payment system, and for the refund process, I want to have a double human validation. Then the refund can append, and it can only be appended once. For a refund subject, I will say that the refund must be exactly in third place or fail. Okay, so he connects to Nats. He creates a Jetstream client, creates a little UID for the order ID, and then he publishes to refund.orderID. And he expects the last subject sequence to be 2. Okay, so he's doing something interesting here where he's like taking, he kind of has like the general structure of what this should look like on a per subject basis. And he's trying to, put some validation around it, which I think is really interesting. I haven't really necessarily seen, I don't think I've seen this before. Unless I'm misunderstanding what this is. Still waking up for the day, but and that's the sequence applies to the whole stream. Yeah, so if you're adding messages to the stream, it doesn't matter which subject that they're on. The sequence ID is going to keep keep increasing on the per stream basis. So if you have 2 orders in your stream, the sequences will be like this: you refund order 1, it's sequence number 1. Then you refund do another refund for order number 1, sequence number 2. Sequence number 3, 4, and 5 are the refunds for order numbers 2. So it doesn't really matter what subject that this is on. The sequence number is going to keep increasing. All right. If I write my refund after all this, the last subject sequence should be 6 in order to maintain ordering. Got it. To get to the current sequence, when subscribing to a subject, the received event contains the sequence. I can store the last subscribed and use it, fetching the last event metadata before writing, as in the business rule example. And then 3, save the sequence of your last write in memory. Okay. Subscribing to a subject.
I want to know what in memory means there.
Yeah, I know. That's when he said that, I was like, wait, maybe I need to.
Which machine's memory?
This. Yeah, I think they mean like, yeah, in their current process, fetching last event metadata before reading example. Yeah, I don't think I'm following this quite yet.
So I think this is 3 options to get the current sequence number, depending on, like, these are 3 points where it might happen.
Oh, okay. Yeah, so it's not necessarily like step by step. It's like here's some options for.
I think it's 3. Yeah, I think so. That was how I read it.
Yep. And actually, this is something that we do have come up quite a bit. Is people do want to kind of get at the last sequence number for a stream a lot, and a lot of times people will do that by doing like stream info, right? Sometimes people will over abuse stream info. There's actually like a lot of ways to get at that data when like a lot of that data actually comes as metadata whenever you get a message delivered to you. And so you don't need to have something that keeps asking, hey, what's the state of the stream? Hey, what's the state of the stream? You get a lot of that info delivered to you in the message. And so that's one thing, we see quite often is people will write something to go like keep updating the state of the stream because they want to use it for some reason, like what's the last sequence number or whatever. But you can get a lot of that stuff, if you're using a consumer, for instance. If you're using a publisher, it gets a little bit more tricky, but yeah, there's definitely multiple ways to get this in efficient ways.
Yeah, I'm curious to see where it goes, but like in that third option or the three options, even the first one, storing the last subscribed and using it, like where's that being stored necessarily? I'm interested to see. Like I think he's
Yeah,
going to
well, this
implement
also
one and two.
assumes that you're like the only publisher, right?
Right, that was my thinking.
So, and yeah, sometimes the publisher just needs to know what their last write was for whatever reason. But there's so many there's so many use cases where a publisher might need to know the state of the stream they're publishing to. But also sometimes that could be very much well avoided. And it kind of goes back to that like separation of concerns and location transparency. Like how much knowledge should a publisher really know about the stream it's publishing to? Um, beyond like, hey, we got it. And so, yeah, sometimes I'll look at that and be like, if you're doing a lot of stream infos, like maybe there's something up with the architecture that might not be working as well for you. But yeah, that's a good point. Too many events. Okay, I have a boiler that sends an event every 10 milliseconds to adapt. Okay, to adapt room temperature, I need to compare the current temperature with the average water temperature from the last hour. Okay, so now he's talking more like we're moving away from Financer. Now we're talking about like an IoT use case. To get this average water temperature, I need to read events from the last hour. It means reading 360,000 events. To make this faster, you can create one snapshot event every hour, okay? And then read the snapshot to validate your business rule. Okay, so what he's doing is he's taking he's connecting a Jetstream, like you said, this in JavaScript, and then he does consumer get with a filter subject, and then he goes and consumes these messages to build this snapshot. Oh, and that's it. Okay, cool. Okay, so this is kind of just an example of like ways that you can take a stream of data, and now I'm starting to understand like what he's trying to do. He has some consuming use cases. He has some publishing use cases, but mostly this is kind of using some solutions from like event sourcing to be able to work with like delegation and trust in some ways, where maybe you have like, let's say you have an organization and that organization just gives you a stream of data and they're like, do what you want with this. You consume it however you want. And it might be that it's a huge data set and you only need a subset of it. And so you could use that to like filter it down. But ultimately at the end of the day, like you're the one that's building what you need to be able to make it consumable for yourself. So whether you're like taking all that data and like throwing it into another stream or creating like some sort of projection of it and throwing that into a stream or a different database or key value store, those are all kind of patterns that we could use to have like a form of delegation. So rather than me saying, imagine Nate's on like some other team in the organization and maybe he's producing like order data. And I'm like, I need that order data. Rather than me telling Nate to be like, hey, now we need an orders API that you need to like maintain for us. Like this is what most teams do, right? They have like an orders API and then they like APIs are like the contract layer between all of this. And there's still a contract layer between us, but instead of API, the contract is actually at the data layer. So it's less about like what endpoints you expose to me and more about, hey, we offer this set of data and we'll at least like guarantee this data will remain consistent, and that's a challenge in and of itself. but it does open up a lot more possibilities to the point where now I have all that data and I don't have to go like knock on Nate's door when like something's missing. Or say like you need to add this like extra filter thing in the API. It's now delegated to me that like I'll just go consume that data and make it whatever shape I need it to for my use case. And so that's kind of what I'm reading. I'm reading between the lines a little bit here, but like there's a little bit of that injected into this article, right?
Yeah,
So
and one thing that I think was interesting was kind of in the intro, he goes over, how the fear of eventual consistency is expressed. The front end
mhm.
needs the answer directly. The business process needs to be validated with perfect data. My next page needs fresh data. And the thing that struck me a little bit here is, especially coming from more of a front end centric world, I think a lot of developers have assumptions about these things, right? A lot of people think data needs to be perfect. And the fascinating thing is when you get into distributed systems, how much those requirements kind of fall aside oftentimes. Like we don't actually need as perfect or as up to date data oftentimes as we think we do as
Right.
developers. And the power and flexibility of distributed systems being that not having some of those constraints, not having an assumption of instant consistency, of perfect trust everywhere. You can kind of see the layers you have to add on architecturally to actually get some of those guarantees. But as I mature as a developer, I feel like that was a big learning curve, was realizing many business applications and use cases don't actually need those guarantees or don't need guarantees that are 100%.
Yeah. Well, it's worth thinking about what you want to invest in being like, I mean, you can never have guarantees. That's the thing. That's the big
Right.
lie is that you can never in
That's true.
distributed
Even
systems,
RDBMS.
you can never have real guarantees. There's like no such thing as like true, exactly once delivery,
Yeah, technically
there's
nothing will
just,
be 100%.
yeah. But like, I try to explain this a lot to folks, especially when they're learning Nats, is that there's like yeah, Wayne, but the TV said, yeah, exactly. But like especially when a lot of people start using Nats, they start using Nats, they're like, this is cool, and then they like start learning Jetstream, they're like, this is really cool. And what they end up doing is they started with Nats, and they had this like architecture that's actually like pretty good, where like they were using Nats um, to send all their messages between their clients. And maybe they're using like microservices. Maybe they were pushing a little bit of data here and there, but they weren't persisting anything yet. And they had a very simple model for everything, which was great. And it worked really well. And like Nats actually in practice just works. Core Nats just works insanely well. It's like, it's so solid. It's unbelievably solid. It works very, very well. Um, and Jetstream introduces more complexity because obviously whenever you have to save stuff on disk, now things get a lot more complex. Now we have to figure out how to distribute that stuff, and now we have to have a raft protocol and consensus, and just now we run into all the real distributed systems problems here. But like imagine you have core nats and then you learn about Jetstream, and what people end up doing is now like everything that they do is like a Jetstream. So they just have like Jetstreams everywhere, and then they're like, well, why is it slow, and why is this hard to wrangle? And it's like, well, because you took things that like just because you can have persistence doesn't mean everything needs to be persisted,
Right.
right? And people often run into this like thing where they had a perfectly fine working system where things might be talking using RPCs with each other, and then they're like, well, I'll just like put Jetstream in between here because I'm sure it will be nice to like have all of my RPCs persisted. But you've just like adopted a problem that you might not have even really needed like to begin with. And so yeah, like I would recommend really thinking critically about not only how your data flows, but like, should it be persisted, right? And also to Nate's earlier point, like, how clean does your data need to be, and at what stage? Like, what kind of guarantees do you need about the shape of your data? Because like that also affects a lot of things. I know, I talked kind of in effect about this a couple of weeks ago about this idea of, well, what happens when you have like all of these IoT devices like everywhere, and they're all sending data, and they're all working off different versions, because maybe this is like a consumer IoT device and they're all going to have different versions, and you can't really control what's going to be going into this initial stream. Like, that's the reality. You cannot put some level of enforcement and expect these guys to play along. And rejecting all of these is going to create more problems, right? So what do? Well, you kind of assume that this stream we're just going to name this stream the garbage stream. Because this stream is going to have a bunch of garbage in it. And that's fine. Just assume you're going to have a bunch of garbage in it. Then you could have some service, some processor over here that's going to take the garbage and throw it away or massage it or do whatever it needs to do to turn it into something that might be useful. And now all of a sudden over here, we have the non-garbage stream. And I know this is just standard stream processing, but like the cool part is that like this doesn't have to go through multiple layers of technology in order to work. This can all be done in NATS. You write a little service. It's a consumer and a publisher. You have all these things publishing on this garbage stream. And now you just have like an ingestion pipeline, right? And this is what I'd recommend to a lot of people where you might have these kind of like softer edges that are you have less control over, right? Rather than trying to create some sort of validation layer up front and put up a wall right here, it might be more tenable to actually just say, no, we'll accept all this stuff, we'll process it, and we'll make sure it's clean by the time it gets over here, right? And yeah, maybe stuff goes over to a dead letter queue. That's a good point, Bastian. Like maybe some of this stuff goes over here to some like this is where all the garbage now goes, and we can have a human look at it and decide if we need to do anything about it, right? Yeah, the DLQ is essentially the same thing. But there's a lot that you could open up here, and especially from a security standpoint, like you'd only want these IoT devices to be talking at an endpoint. And so yeah, this is essentially like a job processing queue. Like we've all done this. This could be a work queue that's put in. But it's kind of worth separating. Like to me, you could look at this as a work queue, and that's maybe like an attribute of it. But it really is like taking a hard opinion on the shape of your data and what you want to do for that. And yeah, Splunk is a way of kind of ingesting logs and filtering stuff out. That's like these patterns are everywhere, right?
They solve similar problems, yeah.
We want to take things from the outside world and we want to like distill them into things that are usable. And a lot of people think that you might have to do the whole collecting, and processing outside of NATS before you get it into NATS. And what I'm proposing here is like, no. You can do all this inside of NATS. In fact, like this thing over here, this whole like garbage stream, this could also like, if you don't want it even bugging, maybe these things are like, maybe again, back to trust. Maybe you're worried that these things are going to just hammer like your NATS cluster in some way, shape, or form. And you're like, I don't even want to trust those to even touch my NATS cluster over here, which is fine. Like you can go put this in its own NATS cluster and be like, this is the garbage NATS cluster. So maybe we do want to keep this up because all these things want to talk to it. But we also build it in a way where we want to limit the blast radius, right? We want to limit the blast radius of when trouble happens over here, we can then have this garbage stream inside of this garbage NATS cluster where all of the riffraff and IoT folks are going to be hounding it. And then we just source this stream, or consume this stream either inside of this cluster or in another cluster. And that's when we decide what to do with it. So like there's a lot of really interesting things that you could do with NATS in that way. And I really do like the idea of being able to isolate some of these things. And just a similar example would be like, maybe these aren't IoT devices, but maybe, just maybe, you're running a web app. And let's say web app. And you want your front end to be in NATS, right? But then you have your actual corporate cluster. You have your actual corporate cluster over here. And you don't want like all the web app users to like be hitting your corporate cluster directly. Maybe your security team's like not cool with that. So what you could do is you could just have a cluster that's like, and like maybe there's like no Jetstream in it. Maybe this is just a connection cluster. But like that allows your web app clients to connect to this cluster and do whatever they want with it. Talk to each other, talk back to the cluster in a more like secure way. What am I doing? All the web apps will talk to this. and then this will then kind of proxy all that communication back over here, whatever needs to be communicated. So you kind of now have like this glorified, I'm going to say front end cluster. You kind of have this like glorified like WebSocket server essentially that all of these like web app, front end web apps are like connecting on. And they can talk to each other directly. They could talk to backend services if they have the permissions, but they're all isolated to this one cluster. So any riffraff that happens in here is very controllable because you can control exactly what goes over the wire over here, which is really, really nice. So that's another pattern that I've encouraged people to do when they're like using Nats as like a WebSocket server for front end clients is like, if you're worried about them connecting directly to your cluster with all your other stuff on it from either a security perspective or performance perspective or whatever, then you could just put another cluster in front of it and leaf node it. And that's the beauty of leaf nodes is you could really like have a lot of that kind of like isolation control, which I really, really like. So you can do the same thing with like IoT devices, like I said, in Jetstream, but you could also just do it with like web apps. Sorry, go ahead, Nate.
I was gonna say it's a bit of a side question, but it does touch on leaf nodes here. Andres from YouTube said, kind of an off-topic question, but what are the known limits on the number of leaf nodes? I noticed some very low numbers on the Synadia cloud plans. Is it feasible for some 1,000 edge devices? I think I'll let you take this one, Jeremy.
Oh, yeah. So leaf nodes are interesting because it's all going to depend on like, sure, there's some overhead in like how many leaf nodes. I don't think there's like a hard limit. Really, it's kind of just the fact that like leaf nodes can then be like multiplicative for the amount of like messages or bandwidth that you're going to be pushing around. And like, so it's all going to depend. It's like, are these using Jetstream? Are they sourcing jet streams, or are they just using core nats? Like, where are these jet streams living? What does replication look like? So like, but I don't think there's necessarily a limit. Like we're working with customers who have thousands and thousands of leaf nodes that are connecting in, and so
Yeah, he was asking about Synadia cloud plans, and I think one distinction here, if I'm reading the message correctly, a leaf node is not required for every device or client. So you can have leaf nodes in your cluster. Those are all, server entities and nats that are serving stuff, but you can have tons and tons of clients that are actually connecting to that nats cluster. So if you have thousands of edge devices that are not distribution, if you're talking clients, if I'm understanding the question correct, that these are clients on the edge, that's not affected by your Synadia cloud leaf node limits, right?
Right. Yeah, and so if it's just purely a client, then that's not going to bump up the leaf node limits. But if you're talking about an edge device that's maybe like a single board computer and you want to run a NAT server on it and you want that to be leaf noded in, I wouldn't be worried about the limits of the leaf nodes explicitly more than the limits of like, hey, in aggregate, what is this going to look like as far as traffic? What's the traffic profile going to look like? The other thing that's really cool about leaf nodes that you can solve though is that like it's by its own very nature like distributed, right? And so like let's imagine that you have a hub over here. Just gonna grab this cluster again. Okay. Let's imagine that you have the hub, which is maybe in your case it's Synadia Cloud. But you have a hub, and then you want to have a bunch of leaf nodes. I'm just going to start drawing it green for leaf nodes. So you have a bunch of leaf nodes over here that are connecting directly into the hub. Now, if you need to distribute this even further, and this works, I believe this works for Synadia Cloud too. This is a little cheat code. You can also have these other leaf nodes go into here. So like you can have kind of this like hierarchical, it doesn't even have to be hierarchical. This is arbitrary. But like in this case, you could have, leaf nodes on leaf nodes that are connecting in. But you should be paying attention to kind of like what goes over the wire and like what this is serving. Cause like maybe you have this idea of like Synadia Cloud's like our global presence. And then we might have like a more local presence that's like maybe this is like maybe we're building a CDN, right? And this is like a data center somewhere, or some local data center somewhere. And then these are like edge devices over here. and they're connecting into their like data center instead of Synadia Cloud. That's another way to like manage it, right? Maybe like a better way to describe it would be like this is a factory floor, and then these are edge devices. And so like you have maybe a NATS cluster that's running on the factory floor that's like having all being the way for all these edge devices to maybe talk to each other, but also push stuff up to the cloud. And so all of the like by the nature of this system, like all the traffic that's happening here is not necessarily the exact same amount. It's not a one-to-one mapping of traffic that's all going to the cloud. There's going to be some traffic that's going to be routed internally here, and there's some traffic that's going to be pushed externally to the cloud. And so if the nature of your system looks like that, this could be a really good model, right? Where you have like a hub, spoke, essentially. Hub, spoke, or whatever, however you want to call it. But yeah, you can essentially like daisy chain or like leaf node, a leaf node, and you shouldn't have many problems with that.
And he did
But
give some clarification here. Andres says, I was referring to the one leaf node per single node computer to make use of edge device local clustering, not the site gateway where hundreds of clients connect to.
Gotcha.
Yeah, I believe that is what you were speaking to.
Perfect. Yeah, so this actually makes sense in this context. You mentioned local device clustering. In this case, you would want to probably use more of a model like this where you're creating a sense of locality, right? And so you can think about it this way: is you might be running a server on an edge device so that its own services that are all running on that host can all talk to each other via NATs. But then all of these other services can also talk to all these other edge devices that might be local to it. In the case of a factory floor. Now, you might not have locality. These could be consumer devices where there's one running in every home, right? And they don't need to talk to each other. In that case, you could have just like one hub in the cloud or whatever. But from a scaling perspective, if you do have, if your traffic patterns kind of diverge from each other in terms of what goes to the cloud and what should kind of stay as internally routed traffic, this could be a really good kind of model to do. And we've had a lot of people have success with this. So I'd say that's a good way to go. If you have any other questions on like or clarifications that I can go into, but like presumably like you could have a lot of leaf nodes. But if you're like having all these leaf nodes like sync all of these different, jet streams to the cloud and there are R3s, like you might be running into trouble, when you get to thousands. So like, that's what I'm trying to say is like really Jetstream consumers, replication factors, those are going to be some of your biggest factors in what the scalability of like a leaf node deployment looks like, not necessarily the amount of leaf nodes.
And he said the use case is on gateway persistence / buffering and transmission when internet is back.
Mm-hmm. Gotcha. So yeah, you could do that on an individual level, and like we have this as examples and inside of electric vehicles or other IoT edge devices, where yeah, you might have a stream here, and we'll use it for like you said, some internal buffering of messages, and then when they go back online, they could either send it directly to the cloud if they're directly leaf noded in, or they send it to whatever other hub they're associated with, and that gets forwarded to the cloud. Yeah, totally doable. It's just worth kind of like at the scale that you want to do it, figuring out what's feasible and what kind of technology you need to run. You might need to run multiple clusters, depending on your scale. You might need to be running, a I guess constellation of leaf nodes, depending on what you want to do, but like totally possible either way. It's just like finding the right architecture for what you're trying to solve for.
Right. Yeah, you said I want to get rid of the combination of local / bespoke on disk buffering and processors for MQTT retransmission.
Dude,
which makes sense. There's a lot of complexity in there.
Yeah, and Andreas, the Synadia cloud plans, like, yeah, honestly, like it's just hard to figure out how to price a leaf node, like because
right.
That's been our biggest challenge, and it's not even just with Synadia Cloud. It's also with like our enterprise contracts. When like people want to run a leaf node, like here's what a leaf node can be. It could be like a toothbrush. It could be like a retail store. It could be a factory. It could be a vehicle. And those things are so different from just the economics of the particular business. And so it just gets really tough to figure out how to price leaf nodes for one thing. So it's going to be, I'm sure it's going to be a continued iteration for us to figure out how we do that. But yeah, like we want to do value-based pricing for leaf nodes, but it's kind of hard to pin down. And we want to try to figure that out a bit more.
And depending on your use case, I know it might not make the most sense pricing wise, but in case you missed it, if you scroll down to the bottom of the pricing section for Synadia Cloud, you can get additional leaf nodes for $5 a node on any plan. So if you had different requirements, you are able to expand it, which again, I don't think it's a technical limitation fundamentally. It's more just pricing decision.
Yeah, and this is just a little preview. This is actually coming out today. I don't know if we've released it yet. Oh, sorry, this is on this Synadia platform products, Synadia Cloud.
Yeah, we have.
We did launch it. Oh, cool. For those of you who have been interested in it, if you are running your own NATS cluster, but you want to use Synadia Cloud as like your dashboard and monitoring and management layer, but you don't necessarily need to use like the global network, but you just want to use it for your own NATS clusters, for $49 a month, you can add your own NATS system, which is sweet. I need to make a video on this. I haven't tried it yet. It just launched today in beta. So I think that'll be a fun thing to play with at some point. But yeah, like you can fire up your own NAT server, walk through the configuration. I think in about like 5 minutes, you have like Synadia Cloud kind of managing all of that NAT server for you. Managing like the users and jet streams and all that stuff for you with the cool UI. So if you're interested in something like Synadia Cloud, but you're already running your own NAT server, and that was really like the issue for you, you can go for, again, $49 a month, have Synadia Cloud manage all that for you, which I think is really great. Cool. Ryan did ask a big question. I'm just going to run through it really, really quick.
Yeah, while you read that, I liked Wayne's shout out to get a programmable toothbrush, because does it run NATS is going to be the new does it run Doom.
Yeah,
and I love
exactly.
that idea.
I remember like the Primogen doing his big Doom video, and I always thought like, hey, I wonder what that would look like on NATS. So Ryan says, I have resources both on premise and in Synadia. Is it possible to link these in any way? Synadia Cloud allows you to add a remote system, but I'm sure if it's just a managed self. Okay, so yeah, so the Ryan asks in the chat, and I think this is going to be too hard to show on stream. But it's really just about, hey, is there a way to like link two systems together? And that's precisely what leaf nodes are for. And in Synadia Cloud, we do call them like remote systems. Yeah, like that's precisely what that stuff is for. Like a leaf node is a way to link two systems together. It's not just a hub spoke, even though that's like the most common scenario. But like, let's say you have Synadia Cloud, a Synadia Cloud account, and you want to link that up with maybe a system that you're running, internally in your organization, or maybe a personal system. Like I have a Raspberry Pi cluster right back here. Let's use that as an example. So I have a Raspberry Pi cluster that I could just simply link to this. It doesn't have to have a hub and spoke. At home. So I have a Raspberry Pi cluster at home that's running 3 nodes, and I could just simply link this up to Synadia Cloud via leaf node. And it doesn't have to have a hub and spoke. Like we don't need to really care who's the hub and who's the spoke. In most of these cases, we can just have these be 2 completely separate systems that like agree on how they want to like send data over the wire, essentially. And so that's what a leaf node is at its core, and it allows you to model hub and spoke, but it also allows you to do like daisy chains or like whatever. It's completely arbitrary. So these aren't clusters necessarily, but then if I have a stream over on this side in Synadia Cloud, I can easily say, oh yeah, I want like a replica of that stream over here in my Raspberry Pi cluster, or vice versa, right? And it makes it really easy to do. I can have microservices talk between them, and so that's kind of the overall concept of leaf nodes in general. Is that like they're not they don't have to be hub and spoke, even though that's what a lot of people use them for. So would I source them all into one stream or mirror them into multiple? That's a good question. It completely depends. I mean, there's some patterns. Like if I have back over here, if I have like these edge devices that all have like streams on them, I've seen it be very common for people to say, hey, I'm going to source these all into one mega stream, on in the cloud, and that's like a totally feasible thing to do. A lot of people do that. I could even have it be done in the reverse, where maybe I have some authoritative data over here in the cloud, and the edge devices need to know about them, but they don't need all the data. So they can then like filter and get that like a sourced replica of that, but only a subset of the data. In the case of just having like two systems together, you can kind of figure, do I need a mirror of this, where I just need the data like in a read-only mode that's replicated, or do I want to like just source a subset of that data? Typically, like the way you want to think about it is like mirrors are one-to-one replicas, meaning all the sequence numbers match. When you do a write, it will delegate to the leader. So, for instance, if this was the primary, and then this is the replica, and if this is a mirror that's happening, then when I have a client that wants to do a read, it's going to get the read directly from this, right? Assuming that this is on my Raspberry Pi cluster at home. If it wants to do a write, it's going to talk to this cluster, but Nats is smart enough to be like, oh, wait, no, you actually want to like write to this guy over here. And so it'll actually like delegate the write to the proper leader. So if this is broken, if this connection is broken for whatever reason, you're offline, your wide area network goes out, but your LAN's still working, you won't be able to write to this mirror, right? Because it doesn't exist, but you'll be able to do reads, right? So like that's one of the things. If you're using sources, you'd be able to write directly to this, but this one wouldn't know about any of those writes because sources they're not like one-to-one digital twins or one-to-one replicas. They're just like taking a subset and like feeding it in to the stream, if that makes sense. So those are some of the trade-offs that you have to think about with sources versus streams. Wayne coming in hot. Doom in web UI, like the multi-draw app with backend fed from Next. Yeah, I know. That'd be fun. That'd be super fun to do Doom. Or to do something crazy like that. Nate, we got to think of like a fun Twitch bot to do with Nats. Because like it can handle the traffic. It's not like it's not like what Primogen did was like crazy in terms of traffic. Like Nats could have handled that really easily. So, yeah, Wayne, if you want to put together an example, let me know.
Well, it's one of the cool use cases I've been thinking about a lot is real time like multiplexing messaging system, right? So what Riverside's doing with live chats, right? Feeding multiple chats into one source. I've had a thought bounce around for a while to do something with that, where you could set up a stream to actually be coalescing, YouTube chat, Discord chat, Twitch chat, and making metrics or doing analytics on that in aggregate. I think could be pretty fun and pretty easy to slap together.
Yep. Agreed. I'm going to take a screenshot of like our YouTube chat real quick, and we'll just like rapid fire for the last like 5 minutes. I think we should answer some questions. And yeah, maybe we build something fun next time on stream. I don't know, maybe we mess with Twitch or do some live coding, some live pair programming.
Dude, it's fun. It's always a good time.
I know, that'd be sweet.
Not going to say anything gets implemented flawlessly, but fun will be had.
Fun will be had. There will be many shenanigans, is what I like to say. Okay, so Naveen talks about KV projections. KV is more projections from the blog and can be rebuild what you need, not for persisting the whole stream. Yeah, and Naveen, just on your point on KV, like KV is an excellent place to store projections, I've found. Especially like on a data pipeline, if you're like processing data, imagine you have like data coming from a stream and then you want to go like process it with some sort of service. And then you want to like take the results of that. Maybe you're doing like some sort of windowing or you're doing some sort of data crunching and you want to go store that transitively in a KV so you can like look it up later. Perfect solution for that. And so, and then maybe you like take this data and, store it in another stream. And so like there's a lot of data pipelines that do look like this, where you have some form of processing, but that processing is dependent not only on like storing, but also retrieving stuff from lookup tables, essentially. And like you could just think of the KV as a lookup table because that's exactly what it is. And this is something that's really nice because in a lot of data processing pipelines, it's like we use Kafka for this, and then we use like something else to process the thing, and then we're putting it into another system like Kinesis, and then like we're using Redis over here for our lookup tables, and like this is fine, but it's just a lot of tech. I like that you could use Nats for all this stuff, which I think is pretty cool. So it would be interesting to see if Telegraph kind of agents allow you to pump data into Nats. Yeah, that would actually be really, really neat. I know we're actually working on some cool stuff regarding like data pipelines internally here at Synadia that I think people will really, really like. Just kind of think about what we're doing with Nex, and also like sources and sinks, and being able to like build like Nex functions to like do single message transforms. And then you have all this other stuff available to you, like the key value stores and stuff like that. In combination, you could build out some pretty cool data pipelines. Cool. Ethel says, where do I go to get comprehensive documentation on TLS, N-keys, and all things security on Nats? Yeah, so we have...
And I gave a couple docs links there, but he said the docs links didn't come through. I don't know if that just means they're not clickable, but...
Yeah, if you go to docs.nats.io, we do have a whole security,
that's what I was going to
section
point him at.
that we can cover. We talk about what N keys are. We talk through TLS, but we are in process. And it's been a long time coming, but we are in process of redoing the structure of our docs, and security is like going to be a dedicated section where we talk through all of the authentication, authorization, stuff like that. We'll talk through TLS. We'll talk through what N keys are. A lot of them are simple concepts. They just need to be explained, a little bit better, I think. But if you are interested in kind of learning how our decentralized auth works and how we utilize N keys specifically, I do have a video on our YouTube channel that explains it pretty well. If you go to, if you just search like Nats auth, I'm sure it's going to be like one of the first ones that pop up. This one, the second one that pops up, how to use decentralized authentication authorization. I actually just explain, similar to what I'm doing now with drawing, I'll just explain like what N keys are, how we utilize JOTs, what they represent in the system, how stuff is delegated. And I also go through like a dissection of, okay, what happens when something connects to a NAT server, how do we utilize N keys and the challenge and like everything like that. So you can look at an anatomy of what connection looks like, and how all those pieces play together. So that might be a good start. But I want to cover this in more detail in documentation as well. Good question. Andrea says, this last Raspberry Pi example would be solved by having separate read-write streams for the two directions on sourcing the respective side, right? Yes, Andreas, great conclusion there. We actually have some good tooling here where like you can, if you wanted to have this kind of like bi-directional sync, you would have to be like, it depends on how you want to do it. So our, one of our local Synadians, Jean-Noel Moyne, our field CTO, did publish a blog on this that I think is really, really good. This one, multi-region consistency, have your cake and eat it too. And it doesn't have to be multi-region, but he goes over the different patterns that you can do with this. It's a combination of a lot of features to be able to pull this off. But if you can use stuff like, I can source one stream into the other, and then I could remap these subjects and kind of feed them back into each other, I can actually create this kind of like bidirectional, consistent write system, which is really neat. And so he goes over like how you do all of the different mappings for this. And that's where I'd start. It's a bit complex, but like in his example, he's doing like a 3 region thing. So it's arguably a little bit less complex when you were just working with 2 systems. But yeah, there's a lot of really cool things that you can do to like, essentially what the name of this blog post is, have your cake and eat it too. Because I don't think there's a single technology that's able to do all of this stuff in terms of replication. It's pretty complex. But yeah, I would go through this blog post. It's a really, really good one.
Well,
And that one's just on Synadia.com.
Fundamentally, what he's getting at is one of the best and worst parts of distributed systems is there's always more than one way to do it.
Yeah, just
There's
it's
always
like it depends.
a lot of different ways. It depends is always the answer. And the nice thing, I think, especially with Nats, when you're working the Nats ecosystem, is having the primitives available, having the configuration options available that empower these architectures without you having to, strap on too much manual processors or services or anything like that. It's kind of like, well, how much can just happen at the system level? How much is just handled, at this layer that's so close to the network? And it allows you to easily pick your it depends without that being a negative impact.
Yeah, and it's worth kind of going through all the trade-offs, and like John Noel kind of outlined some of them in this post. But there's just a bunch of trade-offs. Like, how opaque do you want your streams and your data to be? Like, what amount of knowledge do you want your clients to have? Because there's a varying degree that you can have with that. So it's definitely worth thinking hard about. But great question, or a great conclusion about the Raspberry Pi example. And I'd encourage you, if that's what you want to do, to explore this blog post. And play with it a little bit, because you could really create a lot of cool stuff. Okay, well, I think that about like ends it with, or that about ends our time today. Yeah.
That came up quick.
Yeah. Oh, before we do, I'm gonna see if I can pull in Wayne real quick so he can show off his Nats t-shirt. Yeah.
Hey.
Yeah, and this is just an encouragement. If folks do want to, you can call in directly from Riverside. So like, we'd love to have more people on to chat with us. So hey, Wayne, how's it going, dude?
Totally unintentional. I literally just pulled out of the closet today, threw a shirt on. I didn't even know I was wearing it until just now. So like, you can tell what I love, right? So
I love it, dude. That's awesome. Awesome. Well, thanks for joining us for office hours. Yeah, I love all of the energy in the chat.
I'm looking forward to more of them, and they're amazing, and keep up the good work.
All right, cool. Thanks, dude. All right, well, we're going to close out our office hours. Thanks, everybody, for joining, for hitting us up. We'll see y'all next week, same time. We'll talk more Nats, go over some more blog posts, come ready to ask some questions. But thanks for joining me, Nate, and we'll see y'all next week.
See it.
Bye.